We're now going to look at an insertion sort, which are really handy if you've only got a small amount of data in a list, but really slow and poor if you've got a large amount of data in a list. So this is when we choose to use insertion sort, when we've only got a little bit of data. Right, let's look at some data. I've got 7852463, and we're going to sort this data into the correct order. So again, it's easier to work on paper. So I've got my list written out here. Now what we've got to remember is this here is the sorted side, and all of this is the unsorted. So my 7 is in the correct order at the moment, it's sorted. I can then look at the next item. Is 8 in the correct order? 7, 8, yes it is. I now look at the next item, which is 5. It's not in the correct order, so I can drop the 5 out. So we've now can move the 8 along to here, move the 7 along, and insert the 5 at the start of the list. So that's why it gets its name, the insertion sort. So my sorted data now goes up to the 8. My next item is the 2. So again, 2's in the wrong place. I can drop the 2 out, and I can move the 8 along, I can move the 7 along, I can move the 5 along, and I can insert the 2 back at the front. Again, I'm moving along the list looking for the next item to sort. So 2, 5, 7, 8, 4 is the next one that's not right, so I can drop the 4 out and move the 8 along, the 7 along, the 5 along, and I can insert the 4 in there and put my 2 back in. So you can see that my data is becoming sorted as I go along. 2, 4, 5, 7, 8, 6 is the next item to sort, so I can drop that out. I can move my 8 along, my 7 along, and drop the 6 back in. 5, 4, 2, and as I go along, I've now only got my 3 to sort, so I can drop that out. I can move my 8 along, my 7 along, my 6 along, my 5 along, my 4, insert the 3, and put the 2 back in. So you can see there how an insertion sort works.